At the heart of every digital camera we have the digital sensor, and of course the sensor is comprised of literally millions of individual picture elements. Now the camera's sensor size can have a big effect on the size of the equipment. So if you have a large sensor, which is comprised of millions of pixels, then it stands to reason that you're going to need a larger piece of equipment, the camera and the associated lenses, in order to house that larger sensor. And of course, if you go to the other extreme, if you have a very small sensor size, such as those in iPhones and equipment like that, then the equipment can be a lot smaller. The sensor size has a big effect on the quality of the image possible. Now, larger sensor sizes have, relatively speaking, larger pixel sizes for any number of pixels on the sensor, which means that they can gather more light per pixel than those of smaller sensor sizes. This generally equates to better image quality in the end. The depth of field. For any particular aperture setting, you'll find that the larger the sensor size, the more pronounced the lack of depth of field there is. If you have a very small sensor size, then depth of field becomes almost infinite. Now this can be a problem if you're using a very small sensor size camera. You may not be able to affect the amount of limited depth of field for certain situations, whereas with a larger sensor you can pronounce the limited amount of depth of field very easily. The possible ISO range. Now this is the sensitivity adjustment of the sensor, and you'll find that a larger sensor usually allows you to have a larger ISO range into the high ISO areas, because the sensors, each individual pixel is larger, therefore we can achieve a much greater sensitivity range. Coupled with the ISO range is the sensor noise. The larger the sensor, generally, the less sensor noise. All electronic equipment produces electronic noise, and if you have very small sensors associated with the very small pixels, it means that the signal, which is the light, to noise ratio, which is the electronic noise, so the light to the noise ratio becomes less and less, and so noise becomes more of an issue with smaller sensor sizes. Practical aperture limits. As the sensor size becomes smaller, so the optical arrangements of the lenses and things become smaller as well, and it gets to a stage where diffraction becomes a problem with designing lenses and things. And so you'll find that with the smaller sensors, especially the very smaller sensor sizes, you'll have a very limited aperture range available for you. Magnification of the image at any particular focal length. So we know that lenses have focal lengths measured in millimeters. Now on a 35mm film camera or a full frame digital camera, a 50mm lens will give you an image that looks approximately life size. We call that 1:1 ratio. Now if you were to apply that same lens to a 4/3 size camera, which has got an area a quarter of the size of the full frame camera, you'll find that it has a magnification factor of 2 times. So a 50mm lens won't give you an image that looks like it's 1:1, a standard size image. It will actually magnify the image by 2 times. So any particular focal length will have a magnification factor, or what's called a crop factor, applied to it. Cost. It costs a lot of money to make large sensors. So you'll find that a smaller sensor piece of equipment generally tends to be smaller, but be less cost. And of course the equipment size is also proportionally smaller usually. Now in this diagram, I'm just showing you the full size, the full frame area of a film, of a sensor or film, as in old money. Okay, and it comes out at 36 millimeters by 24 millimeters. So that is the size of the sensor. And of course, the sensor is comprised of millions of individual little. Now, if we show you an APS-C size, now this is what's called a crop factor size. Typical of Nikon, Pentax and Sony, it has a crop factor of 1.5. So if we were to use a 50mm lens from a full frame camera on a crop factor sensor, it will actually magnify by 1.5 times, give you an image that appears to be 1.5 times larger than if it was just used on the full frame camera. And of course the APS-C comes in two values. Canon have made it a 1.6 crop, which means that their sensor is a little bit smaller than the Nikon type. The 4/3 type cameras, people like Olympus, they produce cameras with a sensor this size, and you can see it's a quarter of the area of the full frame camera. Okay? And it's got a crop factor of what we call 2 times. You can see the size of the sensor there. A 1-inch type, a lot smaller. And of course each of these sensors could have the same number of pixels, but of course each time we shrink the size of the sensor, then all the pixels have also got to shrink proportionally. And by the time we get down to compact cameras, we get into a really small sensor. So all of these issues here become more prominent the smaller the sensor size. But of course, we need to determine what sort of photography we want to be using the cameras on. If you find that your full frame camera system never comes out of the cupboard because it's just too big and heavy, then you may well find that one of these smaller systems is more to your liking, and if you use it, it's going to be of far more value than a camera that never gets used. And also these APS-C type digital SLR type cameras have this magnification factor, which is really useful for sports and wildlife photography. So these are often more valued than the full frame. It depends on the type of pictures that you're taking. So as more pixels are squeezed into each sensor size, this affects the quality of the image, the possible ISO range, the sensor noise, and also this ability of the lens to resolve to the limits of the sensor. Now in the days of film, we used film an emulsion, which was a sort of chemical process on a piece of plastic, and that had a limited definition, the amount of detail that could be captured by a film. And the camera manufacturers made lenses to satisfy that requirement. With the advent of certainly the latest types of cameras, the resolution possible from some of the more recent sensors, like 20 megapixels, 30 megapixel, 50 megapixel sensors, there's the potential to capture detail far out resolves the abilities of the older lenses. So if you fitted a film type lens onto one of these modern cameras, the lens wouldn't be able to resolve to the limits of the pixels on the sensor, which is why the camera manufacturers have had to restock their entire lens range to cater for the enhanced abilities of these new sensors. So hopefully this has given you a bit of an idea about camera sensor sizes, but of course the type of sensor that you choose should be determined by the type of pictures that you wish to take, your own abilities to carry the equipment, And of course, if you don't use a camera because it's too big and say heavy, then you may well find that you get far more use out of a maybe 4/3 type camera because of its compact nature. So we need to choose the type of sensor and the type of equipment depending on our own needs.